I'm going to show you the source code quickly of the SISc Parser. This is a front end. Basically, this is a form designer. You can move, say, that button, this is your form designer. At the back of it, this is basically, if you move that away, you will see the SISc Parser at the background. You see that? So this is just a graphed panel, but it is made transparent, so when you normally work, so when you show graph and height graph, that H is height graph, it basically control the visibility of this panel. Okay, so that's the physical components of the parser, and this is a back end, and there you can see your procedures and your types. Now I'm going to take you to types first, and there you will see TSC complex and TSC info. Okay, that is where we start. We start there. TSC info equals a record. Valid, if the type SC value at the end, it's all getting combined into a type SC value. When the value is valid, that boolean is true. When it's invalid, it's false. Need prescalers used to denote a unit. Constant, basically a unit acts the same than a constant, but it needs a prescaler like kilogram or joule or watt. You don't say joule is always like 1 joule. Joule is like, you always say 1 joule. You just don't say like G for gravity. So actually it's GA for the gravity constant on Earth, like that 9.8066 meter per second square. That will not need a prescaler. So need prescaler indicate a unit if that boolean is true. It's like a true unit name, but it's got an intrinsic value that needs a prescaler to be a valid value. Okay, so that's SE info, that part. That's TSC number. That's subpart of TSC number, TSC value actually. So TSC number is like TSC info is a subpart of TSC value. TSC number is a subpart of TSC value. So it's got a stereo boolean, a top num of extended floating point, mid num of extended floating point, and the bottom num of extended floating point. Okay, then you get to the complex, so that's a number part. This is a complex unit vector part. It's got an angle, that's just an angle of extended floating point, a range of T angle. It just tells you where you are, or actually on the positive x-axis, or on the first quadrant, or on the positive y-axis, you say. I can go that way if you want to see everything. Second quadrant on negative x-axis, third quadrant on negative y-axis, on fourth quadrant. So I separate the axis from the quadrants. So because if you're on the axis, you're actually on the axis itself, and the quadrants is between the axes. So x and y, positive and negative sides. So that is the angle of type, and there's a T ignore also, so don't worry what that means. T on positive, T first quadrant, T on positive, y-axis, and so on. Then you've got an SP-deg of type integer 64. That's a long integer, a very long integer. Then you've got the sharp angle. That is an angle smaller than 90 degrees, or 0 to 90 degrees. That is of type extended. The UVX is a y component of a unit vector, and it ranges between -1 and +1. And UVY, that was UVX, and that is UVY, it's a y-axis, or the y-axis component of a unit vector ranging from -1 to 1, or +1. Or is it I? I'm not sure. Yeah, it's probably -1 to +1 to 1. Yeah. TSC units equals a record. So that was TSC number. That is TSC complex. This is TSC units. That is a unit part. So it's got a number, a complex, and a unit, and also an info part. TSC units is a record. It's a kilogram dimension. That is a power of the kilogram base units of the 7 base units: kilogram, meter, second, amp, Kelvin, mole, and candela. So it's obviously got a kilogram dimension. That is the exponent of the kilogram. Or the kilogram power. It's an extended floating point number. Meter dimension, extended floating point number. Second dimension, or the power of the second. Extended. When it's negative, it's you divide. When it's positive, you multiply. And basically, when it's 0, it's ignored. It's a 1. Anything to the power of 0, if that second dimension says 0, there's no time involved. Anything to the power of 0 is a 1, and you basically take all 7 base units with their powers and you multiply them. Chain multiply them with the complex unit vector and the number part to get the total TSC value. There you see your TSC value is a record. That is just a type declaration. And then you got your info part of TSC info, your number part of TSC number, your complex part of TSC complex, and your units part of TSC units. And this TSC number value, that one, that is a base type of the parser, of the SISc parser. That is what it uses instead of numbers, this whole thing. And its stack is of type SE value. It's internal calculation stack, not as TSC number or of extended floating point number like there. That's subtypes, you see. It's actually this whole thing. That is one value is represented by a TSC value, even if it's as simple as a 1. It's 1 angle 0 degrees on the unit vector, with all of these kilogram, meter, second, amp, Kelvin, mole, and candela. All these base unit powers are zeros when you have a 1. The angle is 1 because it's on the positive x-axis, you know. Sign is positive, so 1 plus 1 equals 2. It can be done on the parser. -1 can be done because on the negative x-axis the sign is negative if you rotate the complex number right around. That's why I use that special rotation technique. So it changes the radius sign, or it inverts the sign of the radius every time you hit you go through the rotate through the x-axis counterclockwise. So on the positive axis it will have a positive sign. On the negative axis the radius will have a negative sign, and it will be a simplex number because there's no y component on the x-axis, or the angle is assumed 0. That you see of the TSC complex. So that angle will be 0 if it's on the x-axis, and 90 degrees if it's on the y-axis, or minus 90 degrees if it's a negative y-axis. Well, the sign will be the angle will actually still be 90 degrees, but the radius will be minus a negative number. The TSC number will be negative. Yeah, so you see it's got that components. TSC info, here it's it. Info, TSC info. Number, TSC number. Complex, TSC complex. Unit, TSC unit. And the whole thing is a TSC value equals a record. So this is a base type. The calculator calculates with. And yeah, we are recording. I want to keep it short. I want to show you how many lines of code there is in the program. Let's go right down. Okay, that's the last in statement. Okay, there it is. 25591, 25,591 lines with version 5.1 at column 1. So you will see that column increase when I go to 2, you see, and 3, where the cursor is there. So if I move back the cursor, it will go 3, 2, 1. But that number to the left of it is a number of rows, and that 1, 2, 3 is that 1, 2. Where are we? Sorry, I can't see so well in the dark. Don't worry, this is a number of rows. So this is 25,591 lines of code we are at now. So that's the lines. You see there is the bottom of the code lines. Okay, let's go to the procedures. What is important procedures here? Okay, let's look at a few. Okay, let's say we take complex invert or complex divide left. You see, you can choose anyone. Complex negate. Okay, let's take complex negate. You see that minus function maintain SE value 1. That's it, the in and output IO, because it's a var variable. You can use it as an input and you can output on it. So it's basically an input and an output variable that complex negate functions use. It's of type TSE value. You see, I use this TSE value a lot. You see TSE value there, TSE value, TSE value 1, TSE of type. So SE value of type TSE value. You see, there's SE value 1 of type TSE value. So I've shown you the type is TSE value. So it is a base type of this calculator. So there's complex maintain SE value 1, SE value 1 dot complex angle equals SE value 1 dot sorry for that coughing. Is SE value 1 dot complex and plus pi. Now pi is equivalent to 180 degrees. So I'm basically adding 180 degrees to the angle, and by doing that, 180 degrees is equivalent to an invert. You invert the direction. So you swivel it around, the complex angle get added 180 degrees, and that basically inverts or negates. Sorry, negates. Yeah, invert is a bit different. There's complex. Don't worry about. Yeah, it's called collect left. Don't worry about that. Let's do what's obviously complex divide left. It's an overloaded function, so it's got two forms. You see there and there. There's the other form and there's this form. Let's do this form. Let's maximize this so we can see more. And this is complex. Sorry, where is complex? Let's log to it again. And then unfortunately I haven't put on my light yet. There its code is, and that's we can just go down there. You see complex. You see the SE value there all the time. So we are working with SE values, not numbers really. The numbers is sub part of it, yes. But you would see that the base is. You see how it's done. You can see clearly from the code. If you must use a large screen to view this video. You're not going to properly see the detail on a cell phone. Maybe you must use a laptop computer or a bigger screen to watch, or even a bigger tablet watch this video. Okay, so I'm just going to take you through a few functions. You can see the function names there, like get ray gradients. You see there's a function declaration there. Function get radians angle extended. That's the input, and the output is of type extended floating point number. Okay, let's just see that maintenance function. Maintain SE value. Let's go down a bit, yeah. Let's see, find some of my code. I don't know why I'm coughing like this. I've got the bad flu. Find the word is like a very nice function. Get a word, it's just to get things out of strings. As you see, it's quite involved. A lot of coding. This is nothing. This is only a fraction of that 25,000 lines of code. Okay, let's do complex, that maintenance function, yes, first. Maintain SE complex of SE value. Where's M? You see there, maintain SE value. That's how it looks. That's called a lot to integrate every part of the SE value. You see, we are dealing with SE values here. You see there, the SE value. And intern SE value of type T SE value. So it's terrible, this winter flu. I don't know if it's COVID related, but I have this cough that I've never had before, and it just won't go away. And the winter's very cold here in the Western Cape, in Wellington, near Cape Town, in South Africa. I'm South African. God, it's terrible, really. So you see, I'm handling every quadrant here. I'm handling quadrants here. You see, angle is smaller than 90, bigger than. Don't worry. I myself don't know exactly what's going on, but I'm handling every detail here. That's just a maintenance function. It's a general function that just maintains your SE value. So everything from there, if we go up again, I'm not using page up because this doesn't give you such a good idea of how long the function is. That's just to maintain your SE value. See there, the top of the function, maintain SE value. Okay, a very important function. Let's do a complex multiply function. Complex multiply. It's an overloaded function. You see the overload there. So it's got two forms, this form and that form. Depend on what you have. Sometimes you don't have two SE values, maybe you have I don't know. Well, let's see, the one form is this, and what's the other form? See, that's a difference there. Look at the top line. See, there's a small difference. Yeah, so let's go to say that one. And there's a code. Go down. Okay, says, and there's a second one. You see, there's all your meter dimensions handled. You see, if you multiply, you add. You see that plus signs there. You add the cannula dimension to the cannula dimension. The kilogram dimension to the kilogram dimension of the both sides of the plus of the multiplication sign. So very interesting. Okay. I'm going to, sorry, that's a mistake. I'm going to stop the video now. The main functions that's of the program. I'm not going to show you all the details, only parts of it. Um, Expressions to processes. This basically takes the formula that you type, this function, and it converts it to reverse Polish notation sequences. But actually, multiple expressions to multiple sequences, or I call it a process. A sequence of keys that is equivalent to an expression is called a process. So it's called expressions to processes. So it can convert basically all your formulas in one go, all your expressions in one go on your source line to RPN processes, or you can just convert one expression to one process, a set of keys, a series of keys. This function is actually used in the other main function is expression to SE value, and that actually uses that function too. So it converts the expression to a process, and then that process is converted to an SE value. So I'm going to show you expressions to processes and expression to SE value. I'm going to go through that code, but they are very long functions, so I'm going to use page down here. I must put on the light first, but it's load shedding now, so I can't see properly. So I have a bit of an issue with the load shedding now. So I just want to find the page down key. I hope this is a page, yes. So we are paging down through expression to processes, and you see it's quite a code. I'm actually revealing a lot of secrets here. And if you would actually try to reconstruct this code, you would see it's very well written function, this one. There's expressions to processes. And it actually does certain substitutes here. See. Okay. Let's go fast. It's quite a long function. I'm paging down now. Just one function. All of this. It's a mega function. As I said, there's an int. You see? There's an int. There. Function int. Okay, this is a function int of expression to processes. That one. Expression to SE value is probably impossible to go through even with page down. So I'm just going to go fast through it. See if I see any interesting things. That's a main calculation engine we're going through now. Handle system constants, you see? Things like that. The infinity, you see that lower key equals infinity? It means it's an infinity constant. Okay. Pi, lower key equals pi. If lower key equals pi, that gives a value to, you see the midname, the midname, top name, and bottom name. Now, midname is basically the average of the center between top name and bottom. It's used for differentiation, first and second order. That's why there's 3, not 2. If it was only second order differentiation, you would only need a top num and a bottom num, but because I go to second order, I need 3 numbers, or a 3 split number approach to go to second order differentiation. So there's two differences between three numbers basically. Yeah, so you can see it's like that. So you need 3 for 2. So second order differentiation, you need 3 numbers for your SE values number part. But it's built in type SE value, you see that. So, yeah, we're still busy with the expression to SE value function. It's all one big function. I'm not only you see, if lowercase is an underscore degree, you see, that's where that complex things is handled. That of the unit vector. It's a yeah. It just says it's a value is 1 for a unit vector, and uses SU value as attributes functions also a lot. SU value as attributes. You see there you see it. It's a test. You see, look for certain attributes in the type SE values. Uh, you don't have to understand everything. But as you see, the parse is quite a complex code. I'm still busy with one function, and that function's name is expression to SE value. I won't say it's a main function, but it's a main calculation engine basically. There are other big functions too, especially expression to processes. Quite a big one too, but it's not close. This is the biggest one, expression to SE value. So it's still going on. I'm going to, you see there, I handle log. You see there, log, and that 2 means there's 2 arguments. Next n key, don't worry, that 2 is just a 2 argument function, log 2. Exponent 1 argument, exp1. See there, functions that I'm handling there. I don't know if I'm paging up or down. Don't worry. It's just all the functions and the fractional function. 1 and that 1 and 2 is the argument counts at the end of the functions. You see that next n key equals frac 2. Now there is a function like frac. Integer 2, 2 argument or 1 argument. Now there's an int 1 and an int 2, I think. Yeah, see? So both are separately handled. I think the second argument is it's your quantum, your size of your quantum of rounding or the integer quantum. Round function is a round 1 and a round 2. Let's go up. See, there's int, and then we see round 1. There's the round things. There's a single argument function that round 1, and then we should see round 2 also. So yeah, so it's just handling all the different keys you can get from the RPN. You see. I just wanna. My stack.enabled is equals false. You see that a lot. That should disable the stack at the end of something. My stack. You see that my stack dot SE values 1. So my stack is of type SE value. See, my stack. That is a calculation stack. And that values and that is level 1 of the stack. You see, I just want to note on that. But you see that by stack SE values 1 dot complex dot angle. You see, that's how things are done. Okay, I think I've shown enough. I'm going to stop now. This function is too long. I'm going to paste on quickly. It's a long function, very long function. Probably going to miss the end anyway. Well, only now way I know I'm still in the function is because I recognize the code. So I can try to see if I can get to where I handle the units. There's a system units. You know, you get your units in your library, but you also get your SI units, that is built-in units, that you don't have to look up in the library, and they're called system units, and they are actually in this expression to SI value function. They are built in, they are system values. And if you want to know all the system keys, there's a function, system keys, that check if it is actually a system name. Like black link, I'm not going to do, that's a lot of stuff there. You see, still one function. It's a massive calculation engine, and it cycles through it every time it does a calculation. Because all calculation basically cycles of this engine. So every time you get a new key in the RPN, this engine runs a full cycle. Oh yeah, there you see your units. You see? Come on, let's go to a very simple. Let's go up a bit. It's very dark. See, when you get this long lists, you see that's units. Let's go to meter or something. Right. No, that's not units. Let's go down again. That's where the SISc is handled. You know, the I, centi I, milli I, steradians, yeah, the SR unit. You see, that's all the prefixes is handled, you know, and the relative values. Okay, and there's gram. I'm going to go to it more exactly. I'm going to use this. You see there on the screen? There I use handle the gram. There you see gram. Decagram, hectogram, kilogram, megagram, gigagram, teragram. So I don't even know all the prefix names. Peta, Exa, Zeta, and Yotu, I think. See, this is the big ones, and that's the small ones. So it's from big to small. And there is how you implement the unit. And you will note that neat prescaler. You remember that neat prescaler of SE info, of SE value? So my stack.se values 0.info.neat prescaler equals true. You see that true? Because it's a unit. A unit has a true prescaler, neat prescaler setting. And you can check all this rest. How the unit. And there I push a stack. And you would see my stack SE values. You see? So we're working with SE values here. See that very clearly. Okay, I'm going to stop this video. Where do I do that? There. Okay, my friends, I hope you enjoyed the video. I'm not going to go through the whole 55,000 lines of code. Why?